guys, and welcome to today's lesson. Today we're going to be looking at grade 11 and grade 12 organic chemistry. It is important to note that this is for the IB syllabus. The CAPS syllabus is exactly the same, except you guys do ketones and aldehydes, which will not be covered in this video, but I will do a video on aldehydes and ketones at a later stage. So basically organic chemistry is chemistry that's made up of all the things around us, and they contain hydrocarbons. So a hydrocarbon is a compound which only contains carbon and hydrogen atoms. So there's an example there at the bottom. So I'm sure you've seen it. It looks like a little train. You've got your carbons and then your hydrogens bonded around it. It doesn't just have to be hydrogens that bond with it. There can also be oxygens, there can be halogens, all kinds of things can bond with it. But the most important part is the fact that you have to have carbons that are bonded to each other, and it is preferable that there are hydrogens involved in some way. Right, so the different ways in which hydrocarbons would present themselves are called a homologous series. So we're going to go through all of the homologous series. There's a whole bunch of them. The very first one is alkanes. And alkanes is, like you can see over here, a single bond between each of the carbon atoms. There's no double bond. So that means this molecule is saturated. It means that there is no other bond that can break off for there to be an additional compound that's going to come in. It is saturated. There are always single bonds with alkanes, and the functional group of an alkane is a saturated hydrocarbon, right? And when we name it, it always ends in an ane. So let's go have a look at how we would name it. So if you have one carbon, it's meth. If it's 2 carbons, it's F. If it's 3 carbons, it's prop. If it's 4 carbons, it's bute. So these rules apply to all of the different homologous series. Anytime you have to name them, you have to remember that. The other thing that is important to remember is that once you go from 5, then it's your pent, heps, hex, as you normally learned in grade 6 when you did all those cute little shapes. The same thing applies here in terms of the naming. Alright, so let's quickly have a look what methane would look like. Methane is, remember, meth is just for 1. And if you remember carbon has got 4 valence electrons. So there, and there. Which means there's essentially space for 4 more electrons that need to bond with it. And that is where the hydrogen comes in, why hydrogen is a perfect one to bond with it, because it has 1 electron to donate. So that's why you'll see there would be 4 lines around the carbon. And we would call this methane because there's only 1 carbon and there are no double bonds. Additionally, it is only bonded with hydrogen. So this is what methane would look like. Okay, let's go have a look at the next one. So the next one, when we have 2 carbons, remember I said 2 is eth, so this would be ethane. Now once again, carbon has got 4 valence electrons, which means that it has 3 spaces because the other space is taken up by the other carbon. Right, and this is what ethane looks like. Then we get propane. Propane is 3. And once again, we are going to have our 3 hydrogens that bond around there. Or 2 in this case, because it only has 2 spaces. Alright, and if you go have a look here, you'll notice that all of them ends with an ane. So it's methane, ethane, propane, and that is because of the homologous series. So we look at the homologous series to decide how we are going to name it. Which brings me to the second homologous series, and that is going to be my alkenes. So my alkenes are very similar to my alkanes, except they are unsaturated. Which means there is a double bond between the carbons. Okay, so it's important to stipulate that the double bond is specifically between the carbons. And it is going to look like that. Okay, there's obviously 2 bonds already taken, so there's 1 more space for a hydrogen and 1 more space for a hydrogen. So the reason this is called unsaturated is because something can happen and I can break that carbon away, and then we have more space for hydrogens. So that's why it's called an unsaturated molecule, and we can therefore take it from an alkene and make it an alkane in this case. And we'll get to all the different ways of doing that in another video. Excuse me. So the functional group of an alkene is going to be a double bond. Is a double bond carbon. Okay, so if we have a look at this one, we are going to have to just have a look there and see that I only put 1 hydrogen there, because I always have to go count. Each one of them has to have 4. 1, 2, 3, 4. So that carbon is fine. This one has got 1, 2, 3, 4. This carbon is fine, and then 1, 2, 3, 4. Perfect. So we always need to have 4 bonds. All right, now we have to go and name this. When it comes to alkenes, it is important to state on which carbon the double bond forms. So let's make this one the first one, the second one, and the third one. We like to number it from the point where the double bond starts. So now remember the name, there's 4, so we're expecting it to be called propene. However, there is going to be a double bond on the first one, so we're going to say prop-1-ene. All right. In this case, it wouldn't really have made that much of a difference, because if it had looked like this and I started numbering it from this side, it would still give me the exact same answer. But we'll have a look at the naming in just a second. Today is just to have a look at all the different functional groups and the homologous series that we have. All right, that brings me to the third homologous series that we have, and that is alcohols. So an alcohol is basically an alkane that's bonded with a hydroxyl group. Right, so if we, for example, have this, okay, so this is an alcohol, so an alcohol always ends on anol. So this is 1, 2, 3, so it would be propanol. Right, very basic. The functional group for an alcohol is always going to be a hydroxyl group. Right, the next homologous series, so number 4, is haloalkanes. So it is exactly what it sounds like. It is an alkane that has bonded with a halogen. Right, and if you remember your halogen, we've got fluorine, we've got chlorine, we've got bromine, and we've got iodine. But the names that they get with haloalkanes, F would be fluoro, C would be chloro, B would be bromo, and I would be idio. So how this would work is you would get a normal alkane. So let's give ourselves a butane here, because it's 1, 2, 3, 4. So 4, because monkeys eat purple bananas. Then let's go put a chlorine over here. Once again, I need to number it because I need to state with my IUPAC rules exactly where the chlorine is found. So we're going to start numbering it from this side because it's the side that's closest to my haloalkane. So at the front I'm going to say 2 chloro, and then I'm going to follow it up with my butane. Right, so the chain then is going to be in the front, is going to be the part that has the the halogen. Please don't stress about this now. I will do a video in depth where we go into the naming. It's just important for now that you guys understand exactly what the functional groups are and what the homologous series are and what they look like. Okay, then my fifth one is a carboxylic acid. And your carboxylic acid has we call it a coup. So it is a carbon bonded with 2 oxygens and a hydrogen. What's really important is that the oxygen at the top is double bonded, and then that you have an OH at the back. Now, what's really, really important with the carboxylic acid and what makes it different to an ester, which we're going to talk about now, is the fact that it goes COOH and then you're done. So your carbon would either, your hydrocarbon would either look like that, or it can start at the beginning, but you cannot have anything that comes afterwards. That's how you know that you're working with a carboxylic acid. It ends or begins with the functional group. And the functional group is a carboxylic acid. The carboxyl group, sorry. Okay, so that's a carboxylic acid. We will look into that in depth. And when we name it, it is whatever the amount of carbons is, enoic acid. So this is obviously 4, so it's bute. Let's make our... When I just draw little lines, it's just my shortened way of leaving out the hydrogens. But if they are just little lines, they are supposed to be hydrogens there. It's just to save a bit of time. I'm sure your teacher in class would have done the same thing. So there's 1, 2, 3, 4. So it's going to be butanoic acid. Okay, so that's how we would name carboxylic acid. And that brings me to esters, the very last one. That was number 5. So the very last one, number 6, is esters. And an ester looks a little bit similar to a carboxylic acid because it has the double bonded oxygen at the top and then an oxygen to the side. However, what makes it different is that is in the middle of the group. So it is not something that you're going to find at the end or at the beginning. So there will always, this oxygen with a carboxylic acid, it was followed by a hydrogen. With a ester, it will always be followed with a carbon. That's how you know you're looking at an ester. And what an ester basically is, it's an alcohol that bonds with a carboxylic acid. And esters are worth quite a bit of talking about, so I will do a lesson a little bit later on esters, just so that you understand that a little bit better. The functional group for an ester is the ester group. Okay, so just quickly to recap everything that we spoke about today, if we go have a look at our homologous series, the series that we get would be alkanes, alkenes, we have our haloalkanes, we have our alcohols, our carboxylic acid, and our esters. So those are the homologous series. If we go have a look at the functional group, so let's just do the functional group at the bottom. The functional group for an alkane is going to be a saturated hydrocarbon. The functional group for the alkenes is going to be a double carbon bond. The functional group for your haloalkanes is just going to form part of your hydrocarbon, so this would just be a plain old hydrocarbon. Your alcohol, the functional group, is going to be hydroxyl group. And your carboxylic acid is a carboxyl group. And with your ester, it's your ester group. Just a quick recap of what makes each of those special. If we go have a look at our alkanes, it's just single bonds. Alkenes, what makes it special is a double bond. A haloalkane, what makes it special is if you have a halogen bonded to it. An alcohol, what makes it special is a hydrogen, hydroxyl, so OH. A carboxylic group, what makes it special is the Cu, so the C with a double bond O and then the H. And the ester, what makes it special is the double bonded oxygen with another oxygen followed by a carbon. Okay guys, I hope that was useful. This was just an introduction into organic chemistry. There'll be a few more lessons that follow. I hope this helped. Have a lovely day.